Okay, in this video we are going to talk about how to find the principal argument of a complex number. So let's take our first example. Say z equals to 1 plus I. Okay, so the first step I would recommend is drawing our Argand diagram of this complex number. So this is our Argand diagram. So this is the real part of the imaginary part of z, and then this is the real part of z. This is the positive part, this is the negative part, this is the positive part, this is the negative part. So for this case we have 1 plus I. So to plot this into this graph, this place is around 1 for the imaginary part, then this is where 1 falls for the real part. So if I plot this, we have something like this. Okay, so let's call this angle alpha. Now to find angle alpha, we see alpha equals to tan inverse of the absolute value of the imaginary part of z divided by the absolute value of the real part of z. So the alpha, for this case, alpha equals to tan inverse of absolute value of 1 divided by absolute value of 1. So we know that absolute value of a positive number is still equal to that number. So tan inverse is equal to 1 over 1. So this is equal to tan inverse 1 over 1 is 1, and then tan inverse of 1 is 45 degrees. Now before we go ahead and find our principal arguments, there are some things I want you to know. So principal argument of a complex number is always within the range of minus 180 degrees less than theta p, and this is less than or equal to 180 degrees. So this thing simply means that for every principal argument you have a value that must be greater than minus 180 degrees and a value of theta p that must be less than or equal to 180 degrees. Okay, so I want to show you the relationship between alpha and theta p. Okay, so if you have an Argand diagram, this is the real part of z, and then this is the imaginary part of z. So if you have an Argand diagram, for the first quadrant your theta p is equal to alpha. Okay, so for the second quadrant your theta p is equal to 180 degrees minus alpha. For the third quadrant, theta p equals to minus alpha plus 180 degrees plus alpha. And then for the fourth quadrant, theta p equals to minus alpha. Okay, so you want to memorize this for the upcoming questions you are going to solve in this video. Okay, so in this case we know that alpha is in the first quadrant, so in this case alpha equals to theta p. So theta p equals to alpha, which is equal to 45 degrees. So that's our principal argument for this complex number. Now we can also see in radians, this can also be theta p equals to 45 divided by 180 times pi. So theta p can also be said to be 1 pi over 4. Okay, so let's take another example for you to understand better. In another example we have z equals to minus 1 plus I. Okay, so plotting this in an Argand diagram, you should have, this is it. So this is the imaginary part that we know of z, then this is the real part of z. So minus 1 in this diagram for real part is this place, let's say is this place, minus 1, and then the real part, positive 1, is this part. So the intersection point is this, and then we have our alpha angle it makes to the x-axis. Okay, so alpha, as we knew, is tan inverse of the absolute value of the imaginary part of z divided by the absolute value of the real part of z. So alpha equals to tan inverse of the imaginary part of this z is 1, and the real part is -1. So we have tan inverse absolute value of a negative number here is 1, so this is 1 over 1, which is equal to tan inverse of 1 over 1 is 1. Now note, the absolute value of any negative number is the positive number of that form. So if we say tan inverse, the absolute value of -2 is equal to 2. Okay, so tan inverse of 1 in this case is still equal to 45. So like I said before, you find the relationships between the quadrat and alpha and theta p. So for this quadrat, theta p is equal to 180 minus alpha. Okay, so 180 minus 45 degrees. So 180 minus 45 degrees is 135 degrees. So you can say theta p is 135 degrees, or theta p in radians is 135 over 180 pi. So this is 135 divided by 180, you have 3 pi over 4. So if you like the video, leave a thumbs up button, share with your friends, and subscribe. Thanks for watching.